Hello everyone, this is Mix K. Today I'm going to be presenting a little video on the different types of reactions. So I'm going to slide ahead. Okay, there we go. So if you look at this PowerPoint, I want you guys to take notes while I go over this video. So we have 5 different main types of reactions, and we need to look at the chemical equation to know what type we have. So let's get started with the first type. So our first type is called synthesis. Now the word synthesis means to make something. Like in photosynthesis, plants make their food. Or if you have something that is synthetic, it was made in a lab. So here we have 2 or more reactants combining to make one product. Okay, so how do we know it's a synthesis reaction? It's going to have only one product at the end, one thing after the arrow, because everything is combining to make one thing. So if you look here, we have a little code to help us remember this. So it's A plus B produces AB. So they're combining to make one thing. Another example would be nitrogen and hydrogen combining to make ammonia. So we have NH3 there. So if I was going to come up with a little way to help me remember this, I could think about making a sandwich. So I have meat plus cheese plus bread makes one whole sandwich. So synthesis, they combine to make one product. Decomposition is kind of the opposite. So in decomposition, we have one reactant that breaks down into 2 or more products. So it's one thing breaking down. And if we think about the word decomposition, it means like decompose, like when something that's dead breaks down into smaller pieces. So decomposition means to break apart. So the best way for us to know if something is a decomposition reaction is it's going to have one reactant. It's going to start as one thing and break down into smaller pieces. So here for our little code, we have AB produces A plus B. So that's split up. Or ammonium, NH3, produces N and H. So nitrogen and hydrogen. So in my little comic example here, I have an apple tree. And so I've removed the apples. So now I have an apple plus, or apples plus a tree. So I've broken it down into smaller pieces. So decomposition, we have one thing, one reactant breaking down into 2 or more products. Okay, now the next 2 are replacement reactions. So the first one is single replacement. In single replacement, we have one element replacing part of a compound. So one element, so if you look at this example down here, Ca comes in and replaces the H in HCl. So afterwards, Ca is with Cl and H is by itself. So we have a pure element, a single element coming in, kicking out an element in the compound and taking its place. So the best way for us to know that something is a single replacement reaction is we see that switch and we see that there's an element and a compound on both sides, because there's going to be a single element at the beginning and a single element at the end. So if we look at our little code, we have A plus BC produces B plus AC. So A and B swapped places. So now B is by itself. For my little comic, you can think about someone coming in who's single and breaking up a couple and starting to date one of those people. And so then part of that couple is now single. So Jamie comes in and breaks up John and Amy's relationship. So now Amy's by herself and Jamie and John are together. So single replacement, one single element comes in and replaces part of a compound. So we get a new element and a new compound at the end. Double replacement is very similar, but in this case, we have 2 compounds swapping partners. So instead of a single element coming in and switching places, we have 2 compounds switching part of themselves. So this means that we're going to have 2 new compounds at the end. Now, the best way for us to know that this is double replacement is we're going to see 2 compounds on both sides, and one of those elements is going to be switched on both sides. So if we look at our little code here, we have AD plus BC produces BD plus AC. So if we look, A and B swapped places. So a good way to think about this one, as opposed to single replacement, this one would be like the show Wife Swap, where you have 2 couples and they switch wives for a week so that they can see how each other's lives are. It's not like they're actually switching wives. They're just checking each other's lives out. So it would be also like if two couples broke up and started dating each other's exes. Okay, so the A and B switch partners. So in this actual example, we can see that calcium and hydrogen are switching their partners. So this little carbonate ion and chlorine swap sides. So now calcium is with chlorine and hydrogen is with the carbonate. Or in my little comic up here, you can see that I have Mix K, me. I have a sci-fi book, and my partner, Miss Baker, Miss B, has a fantasy book. And then we swap books. So now at the end, I have the fantasy book and she has the sci-fi book. So part of that little pairing swapped places. Now, this last type is a little bit different. It's a combustion reaction. So in a combustion reaction, it's always going to be the same kind of combination. So we have something that's a carbon-based fuel that reacts with oxygen to produce carbon dioxide, water, and energy. Now, when we see the little code for that, it's not going to always say the energy part in there. So you need to think about what substances are in there. So it's always going to have, the way we know it's combustion, it's always going to have something with carbon and hydrogen and maybe a little bit of oxygen in there too, plus pure oxygen gas producing carbon dioxide and water. So if you see this setup with a different amount of carbons, hydrogens, and sometimes even oxygens in there, you're going to have a combustion reaction. So for this example here, I have wood burning. So oxygen is coming in. The wood is our carbon-based fuel. And when they react, they produce heat and light. That's our fire, water, and carbon dioxide. So H2O and CO2. So when you think about anything burning, that's going to be a combustion reaction. So think about the different things we use as fuel. And most of those things are made out of carbon, hydrogen, and sometimes oxygen. We had wood fire here. We could have a candle burning. You could have the gas from your stove. Anything that burns and produces carbon dioxide and water is going to be a combustion reaction. So now let's look at some examples. So if we look at this first one here, we have a single element and a compound. And when we look at the end, we have a new element by itself. So what must be happening here is iron is coming in and switching with copper. So at the end, copper is by itself and iron is part of the compound. So because a single element is switching with part of the compound, this is going to be a single replacement reaction, okay? Because a single element is swapping with part of the compound. Now here we have S plus O2 produces SO2. So here we only have one product and our reactants are combining to make that one product. So if it's combining, it's a synthesis reaction. Okay, so number 3, we have C2H6 plus O2 produces CO2 and H2O. Now, if we look at this, sometimes people think this will be a single or a double replacement reaction because we see two things on both sides, but we have to look really close. We have something with carbon and hydrogen plus O2 makes CO2 and H2O. So if we look at this setup, this is our carbon fuel reacting with oxygen in the air, making CO2 and H2O. So that's gotta be a combustion reaction. Okay, our next one, we have MgBr plus CuF produces CuBr and MgF. So if we look closely here, we have two compounds on both sides, and we have Mg with Br at the beginning, but then at the end, Mg's with F and Cu's with Br. So Mg and Cu, magnesium and copper, swapped places. So we have two compounds swapping partners, so this has to be a double replacement reaction. Now, if we look at this last one, we're going to see that there's CO2 and H2O. So we might want to be like, ooh, this is combustion. But we have to look closer. At the beginning, it's not reacting with O2. It's just a compound by itself. And because it's not reacting with O2, this isn't a combustion reaction. If we look closely, we have one reactant, and it's broken down into smaller pieces. So if we have one reactant breaking down, that's going to be a decomposition reaction. Okay, so these were our examples. I want you guys to let me know if you have any questions or concerns. Now, I just wanted to show you real quick an example of the assignment you're going to be doing tomorrow. So this next assignment, this comic example, I want you to do an example for each type of reaction where you draw a little comic that represents that reaction. So for synthesis, I had all the ingredients for bread or for sandwiches coming together to make a sandwich. Decomposition, I had my apple tree breaking down into apples plus a tree. Single replacement, I had a single person coming in and stealing someone out of a relationship. So now there's a new single person and a new couple. Double replacement, I had my book and my partner had her book and we swapped books. So now we each have a new book, a new partner. And combustion, I picked something that's a carbon-based fuel and I showed that oxygen goes in and heat, light, water, and carbon dioxide come out. Okay, so for this one, it's gonna be a little bit different than the others. I want you to draw me an example of something that's a combustion reaction, something burning, and show the ingredients going in, the reactants going in, and the products coming out. Okay, let me know if you have any questions or concerns. Thank you so much, guys. I'm gonna end this video right now.